What's up, everybody? This is Sebastian. When you work on an advanced Python project, you probably need to pre-process a lot of data, perhaps image data, or split a large PDF file into individual pages. Utilizing just one core of your CPU is definitely time-consuming, and it would be great if you could process multiple identical jobs in parallel. Multiprocessing in Python is the ability of a system to run multiple processor cores at one time. If you had a computer with just one core, it would switch between multiple processes to keep all of them running. Most computers today have at least a multi-core processor, allowing many processes to be executed at the same time. Today we will be splitting a very large PDF file into individual pages and changing them into image PNG files. Let me first activate the virtual environment in the project number 9. For that, we need to prepare a couple of libraries. First of all, the PyPDF4 library and the Python multiprocess library, and one piece of software, MuPDF, written in Portable C, which will help us process the PDF file. The PDF file that we will be processing today is actually a real complete poetical works by Edgar Allan Poe. Not only it's a great piece of literature, but it also has 394 files, which helps us demonstrate the advantage of multiprocessing. First, let me show you how to use PyPDF4 to get the number of pages. We need to import the library, of course. Then we need to indicate where the file is located, which is in the PDF folder, and then we will assign the number of pages into the variable number of pages, and eventually print that on the screen. When I run the example, I get a warning which I didn't even bother to check what it means, but here it comes. The 394 is the number of pages that I was looking for, so this little script actually does what I wanted it to. With the help of the mu tool, I'll be now extracting one single page from the entire document, and to do that I need to import a library called subprocess. This library helps me run external programs. Then I need to pass some parameters which have to do with the quality of the image that I'm trying to extract. The file is going to be saved into the extracted folder, and the name I'm giving it is 26 because that's the page number 26 that I randomly chose from the entire set of works of Alan Edgar Poe, and I'm also passing the location of the PDF file from the PDF folder. When I run this little script, I get a warning and an information that the page has been processed. Unfortunately, even though I tried, I was not able to suppress the warnings from the mu tool. And indeed, it's an image file. Since we are not going to use this file, I'm sending it to the trash. And here comes the multiprocessing library. With this library, I can check how many cores does my CPU have. One of the things that the library can do for me right now is to print the number of cores. When I run this script, I get the answer 16. So now I'm curious if I can utilize all 16 cores for the extraction of the entire works by Alan Edgar Poe. But before I can get to that, let me extract the entire PDF file on a single core. First we import the necessary libraries, then we go to line number 5, which is a function that does the job of extraction. The function needs just one parameter, which is the total number of pages in the PDF file. Then I'm creating a loop in the range from the first page to the last one. And then I am iterating through all of the pages, calling the mu tool up, which extracts every single page and saves it to the extracted directory. This function, however, doesn't get called until line number 19. Before the function gets called, we obviously need the number of pages. So here we are in line number 13, opening the PDF file, and then in number 14 we are assigning the number of pages into the variable number of pages. Then in line number 18, I am initiating a variable to measure the time that the entire process takes. Then I'm calling the extract function, and then in lines from 23 to 25, I am calculating the time that has passed for the entire process of extraction. Then eventually in line 27, the time gets printed again in the terminal on the screen. The important part about this script is that the job doesn't get redistributed all over the cores of the CPU. Instead, a page is only extracted after the previous process had finished. That's why we can expect this script to take a pretty long time to finish, especially for a very large PDF file like this one. So let us run this script and be patient because it's going to take a little while to finish. Okay, it took 8.5 seconds for the entire PDF file to be changed into individual pages and saved as a PNG. And here are our files. We were able to extract 393 images, and I thought that the PDF file by Alan Edgar Poe had actually 394 pages. Why the last page hasn't been saved? It's not that important for this example. Now I'm curious to see what happens if I redistribute the entire process over the 16 cores that are available. Is the entire process going to be 16 times faster than the previous one? For the many cores example, I need to import the important libraries. Then, just like before, I am defining a function that I'm calling doTheJob, with one parameter, the page number that's going to be extracted. However, this time around, we don't need the loop, and I'm going to show you why. In the section main of our script, we are determining the total number of pages, just like always. Then in line 23, we are getting ready to measure the time for the entire process. The magic begins in line 25. Here is the loop from page number 1 to the last page of the PDF file. Then in line 27, we are assigning multiprocessing to our function doTheJob. The function needs one parameter in line 27, I, which is the current number of page. In line 29, the multiprocessing job gets started. Then our script assigns all the pages to all the available CPU cores. Of course, obviously we don't have as many cores as many pages there are in this one file. Therefore, all the jobs get queued one after the other, yet executed on all the available cores. In lines 31 and 32, we are waiting for all the cores to finish processing this job. Eventually, in the last lines of our script, traditionally, we are calculating the time that has passed since the beginning of our script. Of course, this is just an example how to perform multiprocessing with Python, and you don't have to split PDF files. You can define your own function to perform the job that you wanted. It took only 1.3 seconds to finish the entire job. It is not exactly 16 times faster, yet I still like what multiprocessing can do for me. Let me remove all these files that have been created just now, because I'm going to look at the task manager and graphically see what is going on in each of these two processes. First, I'm going to utilize just one core, which previously took 8.5 seconds to finish, and take a look at the CPU history in order to see if I can detect this process on a graph. As you will see, there is a little lag between the time when I run my script and the graph to be updated on time. Okay, here it comes. A bump is clearly being formed, yet it doesn't seem that any of the cores on my CPU has reached a 100% utilization, in contrast to what you're going to see in just a moment. Now is the time to run this script on all the cores simultaneously. And here is the graphical representation of that. Pretty much all of the cores have reached 100% of utilization. within a very short period of time of 1.4 seconds. In a summary, it pays off to run the script on all of the cores available if possible. Thanks for watching and talk to you soon again.